Hello everyone, welcome to MindSpan Education. Last video we discussed the joint probability density function, and we have seen in case of the discrete where we have the joint PMF, and once we have the joint PMF, then we know everything that supposed to be known for the random variables. Let's suppose for an experiment if we have two random variables defined, and we have also the information of the joint PMF. So once we have this joint PMF, we know how these two random variables are related. We will be also able to find the marginal PMF of those random variables, that is marginal PMF of random variable x and marginal PMF of random variable of y. How we do that in case of the discrete case? So if we have the PMF or the joint PMF of these random variables x and y, in order to find the marginal PMF of random variable x, what we do, we sum this joint probability over all the possible values of y, right? So what you will do, you will sum this joint probabilities over all possible values of y, then you will have the marginal PMF of random variable x, right? And we have seen this in case of the discrete random variable. We have gone through the various examples, right? And if I ask you, how do you find the margin given the joint PMF, how do you find the marginal PMF of random variable y? So you have this joint PMF. What you will do, you will sum this probability or this joint PMF over all the possible values of x. So this will give you the the marginal PMF of this random variable y. Right? Now you can guess that how the formula for the marginal PMF, how the formula for the marginal PDF will look like in case of the continuous random variable. Simply what we will be doing, this PMF will get replaced by PDF and this summation will get replaced by integral. So if we have to find the marginal given the joint PDF, if we have to find the marginal PDF of this random variable x, then we will integrate over all the possible values of this random variable y that it can take. So here we will be integrating from maybe y is equals to from whatever the range that y have, right? So let's write it in general, right? So this integration will be with respect to y, right, in order to find the marginal PMF, marginal PDF of this random variable x. Similarly, if we have to find the marginal PDF of this random variable y, in this case we will be integrating this joint PDF over whatever the range of the possible values that x can take. So this integration will be over x, right? Then you will be having this marginal PMF of this random variable y, right? Okay, now let's look at that how we can find this formula given the joint PDF. Let's suppose if we have this joint PDF of this random variable x and y, the goal is to find the marginal PDF of this random variable x. And if we have to write the PDF in terms of the CDF notation, it is nothing but the differentiation of this CDF. We know from the definition of the CDF, it is nothing but finding the probability that random variable x takes the value less than equals to little x. Here we are talking about the two random variable. What does it mean by this probability that random variable x takes the value less than little x. So we are interested finding the probability of region such a way that for the all possible values of x and y, random variable x takes the value less than little x. So we are interested in finding the probability of region of all the possible pair of x and y that it can take, such that random variable x is less than equals to little x. Right? So we are interested in finding this region. So basically what I am saying, let's suppose, so our probabilities will be distributed over this plane, right? So let's suppose this is x and this is y. That x, random variable x, can take the values and random variable y can take the values. We are interested in finding the probability of region such a way that this random variable is less than some little x, right? So basically we are interested in this region, the probability of this region, right? And if we have to find the probability of the region, what we do? We will have to use the double integration, right? Such a way that this y can take the value from minus infinity to plus infinity, right? So if we are interested in this region, then y is free to take any value, right? It can take any value from minus infinity to plus infinity, right? And so let me use the dummy variable. I will tell you just now that why I am using this dummy variable. So let's take this s and this t, right? So what I have done, I have written this CDF as a function of x, and also we have the joint PDF that have the argument little x. So these are the two different functions, right? So what I am doing, I am just replacing these variables to dummy variables s comma t, right? So that we are clear with the notations and with the variables, right? So in this case, the t can take the value from minus infinity to plus infinity. So what we are doing, we are trying to find the probability of this region. In order to do that, we will have to do the double integration, because that volume will give you the that how the probability is distributed over this region, right? So we will have to do the double integration, and in this case, this t is free to take any value, that is from minus infinity to plus infinity, and we have the constraint over this values of x, values of s, that it can take from value that is from minus infinity to whatever the interested point, that is the x, right? And we are going to do this double integration over this joint PDF. Now we will be using this variable s comma t, right? And here we will have dt and ds. So this is the CDF, right? Our goal is to find the PDF. What we can do, we can simply differentiate this CDF what will be the differentiation of this part. So we are differentiating with respect to x, and again we are integrating from minus infinity to till x. So whatever we will get from this integration, that will be the function of x, and again we are different. So basically this differentiation will be nothing but the integrand itself. So the final differentiation of this part will be this, the integrand. So this is the integrand. Dt, right? And integral will be from minus infinity to plus infinity, and this will be now the PDF of this random variable x, right? So we have achieved what we what we were looking for, given this PDF, how we can find the marginal PDF of these random variable x and y. So how I have found the marginal PMF of this random variable, marginal PDF of this random variable x. Similar way you can proceed and find for the y. Alright, now let's look at an example so that we can have a better understanding of these marginal PDF. Let's suppose we have given this plot that tells us the relation between this random variable x and y, and the PDF or the joint PDF is uniformly distributed. That means for each unit area we will have the equal probability, right? So if you consider this unit of area, then it will be equally likely than this unit area. So all the unit area will have the equal probability, right? So what will be the joint PDF? So the joint PDF, so if you see, we have the total area, that is 1 unit square, 1 unit square, 1 unit square, and 1 unit, total 4, right? And the total probability needs to add up to 1, right? So that means the total volume should be 1, right? So we have the total area, that is 4 unit square, and the height should be 1 divided by 4, right? So this joint PDF will be 1 divided by 4 within this range that we are interested in, and outside of this range the probabilities would be 0, right? So this is, so the all the unit areas per unit areas distributed equally, right, will have the equal probabilities, or any equal area will have the same probability, right? Now we have been asked that what will be the marginal PDF of this random variable x and y, right? So in order to find the marginal PDF of this random variable x, what we are going to do, we are going to integrate this PDF with respect to this random variable with respect to the variable y, right? So you pick any x within this range, right? Then y is varying from 1 to 4, right? And if you pick any x from within this range, then y varies from 2 to 3, right? So if you are picking any x from this range, right, then the y will vary from 1 to 4, and you will be integrating this 1 divided by 4 dy, right? So overall for 1 to 2, for the x 1 to 2, you will have the PDF or the marginal PDF of this random variable x will have the height 3 divided by 4, right? And if you take this x from 2 to 3, then this y ranges from 2 to 3, right? Then in this case where x is from 2 to 3, then integral of this y will vary from 2 to 3, 1 divided by 4 dy. So overall you will have 1 divided by 4. So now from 2 to 3 the PDF will be 1 divided by 4, right? Similarly, if you want to find the PDF of this marginal PDF of this random variable y, then what you will do, you will look any fixed value of y and make sure that you need to be very careful while selecting the range of the values, right? For in this case we will be integrating over the values of y, values of x, right? So pick any y. So you see, for this range of y varies from, sorry, for this range of y, x varies from 1 to 2. For this range of y, x varies from 1 to 3. So here you have to pick the limit of x, right? So you need to be very careful that this y, so within this range x is varying from 1 to 2. For this y range, x is varying from 1 to 3, and for this y range, x is varying from 1 to 2. Right? For we will be splitting this into the 3 region, right? And then we can easily find the PDF. So for this region, when x varies from 1 to 2, so and the probability is 1 divided by 4, so it will be 1 divided by 4, right? So for this particular region, we will have the height that is of 1 divided by 4. And for this region where x varies from 1 to 3, so difference would be 2, and we have the probability 4, so that would be 1 divided by 2. Right? And again, for this region of y, x varies from 1 to 2, so again we will have the probability or the height that would be 1 divided by 4. Right? So this will be 1 divided by 4, and this will be 1 divided by 2, and this will be 1 divided by 4. Right? So we have given this joint PDF, and we are easily able to find the marginal PMF of this random variable x and this random variable of y. Let me give you one question. Let's suppose we have the random variable x and y such a way that they are related to like this. So if we have to write this in terms of the equation, so this is random variable x and this is y, so they are related like this: x square plus y square is less than equals to 1. So what you need to find, and again this joint PDF is uniformly distributed, so what you need to find, you need to find the marginal PMF of this random variable x, and what will be the expression for the marginal PMF of this random variable of y. Right? So let me know in the comment section that this random variable x and y, they are related to with this equation, or if you look at the graphically, this is how they are related to each other. And the joint PDF is uniformly distributed. You need to find the marginal PDF of this random variable x and the marginal PDF of this random variable of y. Let me know in the comment section what is the answer that you are getting. That is all in this video. We will look more about the joint PDF in next video. Thank you so much.